Okay, so on this problem, we have a study that's looking at a group of Americans. So there's a sample of Americans, 120 out of 200 are dog owners, and a group of Canadians, 179 out of 300 are dog owners. And we want to test the hypothesis that Americans and Canadians own dogs at a different rate or proportion. So this is a two-sample, because there's two samples, Americans and Canadians, z-test for proportions. So my HO is that the proportion of Americans minus the proportion of Canadians would be equal to 0 because they have the same proportion, the same percentage of them own dogs. In my HA, what I'm trying to prove is that the difference between the two, the proportion of A minus the proportion of C, is not equal to 0. Because it says different, which is just not equal to. It didn't say greater than or less than, it just said different right here. So there's my HO and HA right there, and I need to find the p-value, so I need to run a two-sample z-test for proportions. And remember, when you do a two-sample z-test or t-test, you're going to end up with data like this right here. Well, with the z-test, yeah, definitely for the z-test, you're going to end up with data like this, like a little table. And so I split it up, and I put the groups go on top, Americans and Canadians. And the categories go to the side, dog and don't own a dog. So 120 Americans out of 200 own a dog. So how many don't own a dog? No dog? Would be 200 minus 120, which is 80. So that'd be 80. And the Canadians would be 300 minus 179, which is 121, would not own a dog, right? No dog for the Canadians. So it would be 179 do own a dog, and 121 do not own a dog. And I want to test and see if these two proportions are different. So I'm going to pull up Staplet here, and let's go back to here, and it's going to be a two-sample z-test for a proportion. We're doing a test this time, not an interval. So a z-test. And my groups are Americans and Canadians. And my categories are dog owner, and no dog. So it'd be 120 and 80. And then it would be 179 Canadians were dog owners, 121 were not. As you can see, that's 200 and 300 right there. So 60% of Americans were dog owners, that 0.60, and 59% of Canadians were dog owners. So they're not very far apart. You can tell that already. So I'm expecting this test to fail, like we'll fail to reject it right here. We're using a significance level of 0.05. So on this one, let's go down and do our test now. We're trying to prove that they are different, so not equal to. And so I perform inference, and I get 0.9406. That is way too high. So 0.9406, we're looking for 0.05, and it ends up being 0.9406. And so not only do we not prove it, we didn't come close to proving it. It's more likely that they're equal, because they're almost exactly the same, right? 59.67% versus 60%. So my conclusion would be, based on a p-value of 0.9406, we do not have convincing evidence that Americans and Canadians own dogs at a different proportion. We would have needed the p-value to be below 0.05 to have convincing evidence. So we're not even close to convincing evidence on this one. So yeah, that is a two-sample z-test for a proportion. You use it to find the p-value, and you come to a conclusion based on that p-value. Get used to making that little table right there on a question like this.